Happy Tuesday. This week is almost over, which is awesome because I definitely need to go on another break. But I'm going to do something a little bit different today. I'm going to talk about something that's science related because, we don't have to stick to politics. We could talk about fun stuff, cool stuff. And I think it's a good way to break up the stuff that's happening in the news that we don't really want to dwell on, but we have to be forced to dwell on. So we're going to break it up today, do something different. So we're going to talk about the Cosmic Tarantula caught by NASA Webb, or the James Webb Telescope. So this is from nasa.gov. So it's got to be trustworthy, right? Hopefully. I mean, this is a pretty sweet image right here. I don't want to save it to desktop, but still, it's pretty nice, pretty sweet. Once upon a space-time cosmic creation story unfolds, thousands of never before seen young stars are spotted in stellar nursery called 30 Doris, captured by NASA James Webb Space Telescope, nicknamed the Tarantula Nebula for the appearance of its dusty filaments. Previous telescope images. The nebula has long been favored by astronauts studying stars formation. In addition to young stars, Webb revealed a distant background, galaxies, as well as detailed structure and composite of the nebula's gas and dust. Only at 161,000 light years away, the largest metallic cloud galaxy, the Tarantula Nebula, I'm murdering that name, is the largest and brightest stars forthcoming region of the local group. The galaxies nearest our Milky Way is home to the hottest, most massive stars known. Astronomers focus three of the Webb high-resolution infrared instruments onto the Tarantula, viewed in Webb's near-infrared camera, or NIRCam. Region resembles the Barling home, lined with its silk, and the nebula's cavity centered in the NIRCam image have been hollowed out by blistering radiation from a cluster of massive young stars, which sparked pale blue in the image. Only the densest surrounding areas of the nebula resist erosion by the star's powerful stellar winds, forming pillars that appear to point back towards the cluster. These pillars contain forming protostars, which will eventually emerge from their dusty cocoons and take their turn of shaping the nebula. The Webb near spec spectrograph caught one of the very young stars doing just that. The astronomer previously thought the star might be a bit older and already in the process of cleaning out the bubble around itself. However, the near spec showed that the star was only beginning to emerge from the pillar and still maintaining the insulating cloud of dust around itself. Without Webb's high-resolution spectra at infrared wavelength, this episode of star formation in action could not be revealed. This region takes on a different appearance when viewed in longer infrared wavelength detected by Webb's mid-infrared infrastructure, the MIRI. The hot stars fade and the cooler gases and dust glow. Within the stellar nursery cloud points the light of embedded protostars still gaining mass, while shorter wavelengths of light are absorbed or scattered through by the dust gains in the nebula, therefore never reach Webb to be detected. Longer mid-infrared wavelengths penetrates that dust, ultimately revealing previously unseen cosmic environment. One of the reasons why the Tarantula Nebula is interesting by astronomers, but astronomers, is that the nebula has a similar type of chemical composition as the gigantic star-forming regions observed at the universe's cosmic noon, when the cosmos was only a few billion years old and star formation was at its peak. Stars forming regions in our Milky Way galaxies are not producing stars at the same furious rates as the Tarantula Nebula and have different chemical compositions. This is making the Tarantula the closest, i.e., easiest to see in detail, example of what was happening in the universe as it reached its brilliant high noon. Webb will provide astronomers the opportunity to compare and contrast observations of star formation in the Tarantula Nebula with the telescope's deep observations of distant galaxies from the actual era of cosmic noon. Despite humanity's thousands of years of stargazing, the star formation process still holds many mysteries, many of them due to our previous inability to get a crisp image of what's happening behind the thick clouds of stellar nurseries. Webb has already begun to reveal the universe never seen before and is only getting started on rewriting the stellar creation story. The James Webb Telescope is the world's premier space science observatory. Webb will solve mysteries in our solar system, look beyond to distant worlds around other stars, and probe mysterious structures and origins in our universe and place in it. The Webb is an international program led by NASA with its partners in European Space Agency and the Canadian Space Agency. It would have been Russia, but Russia did what they did and got kicked out of the Space Club. Let's see here. Is there any more pictures? I mean, that is pretty awesome, isn't it? You gotta admit, that is pretty awesome. It looks pretty interesting, pretty weird, very detailed. Same thing with this one right here. Looks very chaotic. The contrast of colors. The fact that we cannot even see this with our naked eye, we have to use infrared, is pretty amazing. Let's see here. That was. Let's go ahead and take a look at these pictures. Oh, no, I'm not doing a video. Cliff sonograph. I want to hear this. Let's hopefully this goes through. Yeah, pretty trippy. Let's see here. That's probably just the video. Some more ring nebula sonification. Where's the pictures? I guess that's just sound. Let's see here. Detects carbon dioxide in exoplanet atmosphere. Wow. We're actually detecting planets. Man, this is pretty advanced. You know, several years ago, this wouldn't even be a single thought. Let's see here. What else is here? Webb captures stellar gymnastics in Cartwheel Galaxy. Man, this stuff is just amazing. Let's see, the image from the Webb mid almost looks like a jellyfish. See here, where? See here, giant. Oh, that's Hubble, which is a little bit older. And even this was advanced for its age. And just imagine what the next generation telescope is going to bring. See here, what's under latest? NASA discuss status of next Artemis moon. Yeah. Let's see here. Oh, this is just a postcard, post stamp. See here. Latest. Oh no, let's see here. What else is on NASA TV? Galleries, image of the day. Oh, that's pretty nice. Um, dude, seriously? We saw this picture. The crater farm, the three impact craters displayed in three-dimensional perspective of the surface of Venus, taken NASA Magellan, the first deep space probe launched by a space shuttle. Wow. Let's see here. 17. Jupiter, rocket, of course. The moon. Wait. Apollo 15 catches the Earth on horizon. Is that the moon right here? And that's the Earth? Either way, it's pretty amazing. See here, galleries, usage and copyright. Well, blah. The insignia metal logo worn shall not be used for any purposes without explicit permission. These images may not be used by a person who's not a NASA employee. Blah. You know, I really don't care. If NASA wants to copyright this video, that shows more about them than it does me. See here, is there anything more? Nah. See here is image of the day. I want to see more Webb. That doesn't really matter. I'm going sidetracked. I could do this for hours, but I'm not going to. If you're interested, just go to nasa.gov and you'll be able to view at your heart's content. That being said, leave a comment down below. Do you find this stuff interesting? Can you stare at these images and videos for hours at a time? Let me know down below. Also, please smash the like and subscribe button on any of all platforms, or just the platform you're currently watching. But most importantly, have yourself a wonderful day, morning, or evening.